In this example, we're asked to use properties of logarithms to find the exact value of each expression, and we don't want to use a calculator. So basically, we want to show our work or write out explanations of how we did these, especially in our notes. So there are multiple ways, sometimes multiple properties can be used to evaluate these expressions, and sometimes, again, these might not look any different than some of the problems we did in the previous section. So let's look at first at part A, log base 2 of 2 to the negative 13th power. So if we just know the definition or how we evaluate a logarithm, remembering in informal words, this is asking for the power of 2 that would give us 2 to the negative 13th power, or 2 to what power would give us 2 to the negative 13. So just upon inspection in that explanation, we can see this is going to be negative 13. But another way of doing that, so if we want to make just a little note, remember this is the power of 2 that gives us 2 to the negative 13. So that's the most direct way, is just understanding that definition. We could also use one of the properties that we just looked at that allows us to bring this exponent of negative 13 out into the front. So when there's an exponent on the argument, we can bring that out into the front and multiply. So another way to do this is to rewrite it as negative 13 times log base 2 of 2. Now if we look at the logarithm here, another one of the properties we observed, log base 2 of 2 is 1. The power of 2 that gives us 2, or 2 to what power gives us 2, this would be 1. So negative 13 times 1 gives us negative 13. So multiple ways to arrive at that same answer using the different properties. Okay, let's look at part B. So we want natural log of e to the square root of 2 power. So again, multiple ways to look at it. Natural log, remember, is log base e. So this is they're asking for the power of e that would give us e to the radical 2. So if we want to write that out, the informal way to describe this, but direct but informal way, this is the power of e that gives us e to the radical 2. So just upon inspection, we can see that would be the square root of 2. But again, different ways to look at it. Another way to look at it is if we, again, move this exponent out into the front and multiply. So this would give us square root of 2 times the natural log of e. Well, the natural log of e, the power of e that gives us e, is just 1. So this is just the square root of 2 times 1, which is the square root of 2. Again, same answer either way. So again, both of these ways are useful, and it's just going to depend on the problem and which properties you're more comfortable with. All right, let's look at C. So if we look at C, we can see we've got the sum of two logarithms, and they have the same base. So since they have the same base, we're going to use the reverse of one of the properties we looked at above. It says if you take the log of a product, you can split it into the sum of the two logs, or vice versa here. If I have the sum of two logarithms, I can combine them together into one. So I can combine this into log base 6 of the product of 9 and 4. So this is the same as log base 6 of 36. So now this is asking for the power of 6 that would give us 36, or 6 to what power gives us 36? And we can see that would be 2. So in this case, it's very useful to add these logs together and combine them into this product, and we can, upon inspection, evaluate this log. Okay, now D, this is one of these special cases where you've got a base raised to another logarithm. So you've got a constant base, an integer base raised to a logarithm. Remember, a logarithm is an exponent, so it makes sense that you're raising this 2 to an exponent. So remember, this is asking for 2 raised to the power of log base 2 of 7. Well, log base 2 of 7, remember, is the power of 2 that would give us 7. Well, now I'm putting that power on a 2, so that's going to give me 7. So when the base of the exponent is the same here as the base of the log, we're going to end up with the argument. Okay, last one here, part E. We have two logarithms with the same base, and we're subtracting. So we can combine these together into one with division. So we can combine these into log base 8 of the quotient of 128 and 2. So 128 divided by 2. So this is log base 8 of 64. So now this is asking for the power of 8 that would give us 64, or 8 to what power would give us 64. And so that gives us 2.